A fixed-wing aircraft uses aerodynamic lift to stay aloft, contrasting with rotary wing designs that rely on spinning rotors or ornithopters, which move their wings to generate lift. The broad category of fixed-wing craft encompasses not only conventional airplanes with rigid wings, but also kites, hang gliders, variable sweep designs, and even aircraft with morphing wings. Some variants, like gliders and kites, harness rising air to gain altitude without an engine. Others, such as powered hang gliders and paragliders, propel themselves with motors, including vehicles utilizing ground effect near surfaces. Although piloted operation remains common, some aircraft are remotely controlled or designed to operate autonomously. The earliest record of kite flying dates back over 2 millennia in China, where kites found applications in everything from measuring distances and testing wind to military communication and lifting individuals. Stories suggest even earlier use, such as leaf kites depicted in ancient island cave paintings. By the 13th century, European curiosity about kites began with accounts brought by explorers and was fueled further by sailors returning from Asian travels. Eventually, kites shifted from novelty to scientific instrument during the Enlightenment and into the 19th century. Attempts at heavier-than-air flight trace to ancient Greece, where Archytas reportedly devised a bird-shaped object powered by steam. Medieval and Renaissance inventors and daredevils like Aylmer of Malmesbury and Abbas ibn Firnas experimented with glider flights, though few sources detail their efforts. The template for the modern airplane took clearer form when Sir George Cayley articulated the components of lift, propulsion, and control in the early 19th century. Cayley produced both model and passenger-carrying gliders, while contemporaries like Jean-Marie Lebris and John Montgomery advanced the discipline through experimental glider flights. By the late 1800s, Lawrence Hargrave's investigations into wing structure and box kites influenced aircraft design, even though powered fixed-wing flight eluded him. In 1894, Hiram Maxim tested a massive steam-powered craft, proving the possibility of mechanical lift, but not control. The first sustained, controlled, powered flight by a heavier-than-air craft is attributed to the Wright brothers in 1903. By 1905, their Flyer 3 exhibited extended and reliable maneuverability. Parallel developments by Santos Dumont and Louis Blériot introduced early European records and innovations like the monoplane tractor configuration and control surfaces actuated by pilot inputs through joysticks and rudder bars. World War I elevated aircraft to combat and reconnaissance roles, with pilot aces and synchronized machine guns emerging. Afterward, evolving designs in the Golden Age between the wars saw metal airframes, new engine types, and record-setting long-distance flights. World War II further expanded aviation's scope, introducing military gliders, jet propulsion, and rapid advancements in speed, armament, and reliability. The first operational jets, such as Germany's Heinkel Ho-178 and Messerschmitt Me-262, as well as innovations like the rocket-powered Me-163B, stretched the frontiers of aerial performance. Post-war eras brought sound barrier breakthroughs, strategic airlift missions, and the dawn of jet-powered commercial aviation. Iconic types, including the de Havilland Comet, Boeing 707 and Boeing 747, changed the experience and scale of global travel, while the utilitarian Douglas DC-3 and its military twin C-47 demonstrated unmatched versatility and longevity. Fixed-wing aircraft branches into multiple types. Airplanes propelled by jets or propellers serve across the spectrum of recreational, commercial, military, and research roles, with sizes and shapes dictated by function. Seaplanes take off and land on water either as float planes or with hulls designed for buoyancy. Gliders, which fly without engines, soar on atmospheric currents for leisure, research, or historically, for military transport. Motor gliders mix powered and unpowered flight characteristics. Unique types like ground effect vehicles utilize low-altitude flight for special performance. Gliders advance through generations of materials and performance, from wood and metal to fiber composites. Training evolved from simple primary models to advanced dual-control versions, capable of cross-country flights using updrafts. Variants include ultralight types, emphasizing portability, and in some regions exempt from pilot licensing. During World War II, military gliders provided a means to deliver troops and equipment, eventually phased out as transport aircraft grew more capable. In research, gliders led to developments in alternative wing designs and contributed to the early stages of spacecraft recovery technology. Hang gliders and paragliders enable pilots to control fabric wings or ram air canopies through shifting body weight or manipulating lines. Unmanned types, from paper planes to model and glide bombs, demonstrate the spread of aerodynamic principles into everyday activities and warfare. A kite remains a fixed-wing craft buoyed by airflow and tether tension. Throughout history, kites found uses in military signaling, scientific experimentation. Benjamin Franklin's lightning studies being the most famous, and even antenna and beacon deployment. Sporting applications have flourished, generating activities like kite surfing and landboarding, and special kites are investigated for generating electricity from strong, high-altitude winds. The structural core of a fixed-wing aircraft lies in its airframe, designed to connect aerodynamic surfaces, payload, systems, and, when relevant, propulsion units. Early versions often featured wooden frames and fabric skins, evolving over time to metal and advanced composites. Key components include one or more wings that create lift, stabilized by structures like spars and ribs, a fuselage holding the crew, cargo, and sometimes engines, vertical and horizontal stabilizers for controlling yaw and pitch, and landing gear configurations adapted to terrain or water. Wing designs encompass a wide range of solutions, from externally braced fabric-covered surfaces to rigid cantilevered forms viable as engines became stronger. The arrangement monoplane, biplane, triplane, or even tandem depends on performance considerations. Planform decisions such as aspect ratio and sweep address the needs of slow flight, endurance, or high-speed travel. Variable sweep wings and delta shapes demonstrate adaptability to different aerodynamic regimes. A flying wing is a distinct concept where the crew, payload, and systems reside within the wing itself, lacking a pronounced fuselage. While early work sought range or efficiency improvements, later interest focused on shapes with lower radar profiles, as seen in applications like the B-2 Spirit. Blended wing body and lifting body forms attempt to further integrate lift-producing surfaces with payload-carrying structures, achieving variations in stability and drag management. Aircraft stability and control are maintained not just through basic geometry, but also through surfaces like the empennage, tail, or foreplane, canard arrangements, which help ensure stable flight and trim. The control system is the pilot's link to the craft's orientation and path. Yokes or joysticks for pitch and roll, rudder pedals for yaw, and secondary levers and tabs to fine-tune attitude and aerodynamic surface positions. Automation through autopilot and advanced avionics now allows sophisticated flight assisting or even pilotless operation. Instrument panels provide feedback about airspeed, altitude, orientation, and navigation, ensuring that the pilot or system can interpret and respond to flight conditions. With the rise of digital displays, these instruments are often combined in unified screens, echoing the communication and navigation revolution that paralleled other aspects of aircraft development.